proof is true for k plus 1, and then we conclude because it's true for a particular set of integers of 1, k, and k plus 1, and then we prove that for every succeeding value, that particular mathematical statement is true. So therefore, we can conclude if the statement is true for 1, and if it's true for k and also true for k plus 1, therefore the statement is true for all integers of n or all values of n. So for example, proof by induction, proof that the sum of r between 1 to n, all right, is half times n multiplied by n plus 1, and you are given sum of r is actually represented by 1 plus 2 plus 3 and so on. It becomes n minus 1 plus n. All right, so for in this case, the steps are quite fixed. We have to prove for n equals to 1, n equals to k, and n equals to k plus 1. So we have to do for 3 succeeding values. All right, so for the first part A, proof is true for n equals to 1, as I said just now. Yeah, so for n equals to 1, we sum for when n equals to 1, we have to prove both sides. So first we start off with the left hand side. All right, we start off with the left hand side. So for the left hand side, is the focus is this one for the left hand side. So when n equals to 1, the first step, sigma of r between 1 and n is simply based on this, you got to substitute your r as n. All right, and here is obviously n is 1. All right, so sum of 1 between 1, n is 1. You see n is 1 over here. Pay attention, make sure you have to use the correct notations. A sum for r between 1 to 1 is obviously substituting n as 1. All right, and it will obviously result in 1. Right, and then we will focus on the next step here. The next step, we will actually focus on the right hand side of the equation. All right, so that would be substituting n as 1. Right, so it will be half times 1 times 2. Right, we will actually get 1. So when you substitute n as 1, the left hand side value, which is sigma of r or sigma of any other function given, okay, should equal to the right hand side by substituting n as 1 as well. So if it's 1 and 1 here, so this simply means that the statement is true for n equals to 1, right? So the statement, hence the statement is true for n equals to 1. That is the first step for proof by induction. Your next step here would be you have to make an assumption for the part B. You have to assume that your statement is true for n equals to k. All right, and k is always larger or equal to 1. Okay, we don't do for k equals to 0. It's always 1, 2, 3, and so on. So in this case, because n is an integer, so integer, and we only work with n being larger or equal to 1, positive integers only. Okay, so sigma of 1, now your n has become k. Please pay attention to the correct notation, yeah? So your n has become k. Okay, so in this case, you look here, your n is substituted with k. N here has become k, yeah? Okay, so sum of 1 to k for r equals to half times, so we are substituting n as k. So half times k plus 1. So this is just an assumption, so you leave it like that and you assume it's always true for n equals to k. And this is useful in part C of the solution. So for the part C, all right, we will consider n as k plus 1. So for k plus 1, so we have considered for n equals to 1, we have considered for n equals to k. Now we need to consider for n equals to k plus 1, the successive value, yeah? So for n equals to k plus 1, we got to show that sum of 1 and n here, you see n here is already substituted with k plus 1. You see the n here substituted with k plus 1. Okay, all right. And sum of r, it remains because r is the formula that we are actually focusing on to prove. And then we are substituting n as k plus 1. So k plus 1 multiplied by k plus n plus 1. All right. This was n. We have substituted n with k plus 1. Okay. So we need to prove this. So how are we going to prove that? Simply, so this is our goal. Yeah. Just bear in mind, this is our goal. So in order to prove this, I've copied the goal again over here. So this was the goal. We copied it from the previous last line. All right. So next, what we need to do, we need to work out how to actually achieve this goal. It will simply be sigma of 1 to nr. This was given, right? So sigma of 1 to k plus 1 here simply will be, it's like if you have sum, if you want to find sum of 7 terms, it will be like you look for sum for 6 terms and then you add the 7th term individually. So example, like if you're going to add total sum of 6 terms is equivalent to sum of the first 5 terms at the 6th term. That's what we are doing here. So we are representing the 6 terms as k plus 1 and the 5 terms as k. So for example, we will break it down to sum of 1 k will simply 1 to k plus 1 will simply be sum of 1 to k plus with the individual system, which will be k plus 1. That means you're substituting the r as k plus 1 here. Okay. So if we expand this further, we are going to get half times k plus 1. So this one, sigma of 1 to kr is actually given over here, right? So we substitute n as k, which was the proof and the assumption we did in the step B. Okay, so we copy this down here. This is the answer in part B.